this channel. So in this video I want to show you how to perform this unseen scenario question that has been released by Cambridge, and I hope that this will help you to solve your IG exam that is coming soon. So in this video I'm going to show you how to solve this question using Python programming language, but it can easily be translated to pseudocode if you prefer it that way. Alright, so let's try to understand this problem. And what we have here is a 1D array called patient and a 2D array that contain the readings of this patient. And the readings contain temperature and pulse rates of the patient. So for instance, look at on my right hand side here, think of patient, the 1D array, as a list that contain many names like John Wick, Cristiano Ronaldo, Alexander the Great, Alan Jason, and so on and so forth. So that's pretty straightforward. Whereas the reading here is a little bit complicated, where they said inside the readings, it contains the data stored about the patient. We know that a 2D array here, a 2D list, is basically a list inside a list. So I want you to see that each list inside this 2D array contains the data for each patient. So for instance, John Wick, and we know that the data is temperature and pulse rate. So let's say John Wick has a temperature of 37 and a pulse rate of 120, because it's always so active, alright? And then the second list, again, you can see that I have a list inside a list, and each list contains data for each patient. And say Ronaldo, let's say 26, pulse rate 99. And Alexander the Great, let's say he has a fever 39 and pulse rate of 85. Oh, it should be a comma here. And then last but not least, Alan Jason, we have 23, basically dead, a pulse rate of 0. Okay, cool. So that's about it. That's what is inside of reading. Just one note here is that you do not need to do any of this. Just assume that they have been created. Alright, as mentioned here in the last sentence, you do not need to initialize the data in the arrays, and you just need to assume that they have been created, and your codes should cater to any data that the user is going to provide to you. And here we have a requirement. Temperature reading should be in the range of 31.6 to 37.2. Pulse reading should be 55 to 100 to be considered normal. So I'm going to create a variable called min_temp. You might not know why this is needed now, but as we code later, you will know that it will be easier to have this variable in place. Min pulse is going to be 55, and max pulse is going to be 100. I mean, you can do that without this variable declaration, but I personally found that it's easier for me to use them later. Alright, that's it. Next one, the hospital number given to the patient is used for the index on both array, and this is a value between 1 to 1000. So an index is basically a position that allows programmer to access a particular element in the array. So let's say I want to access Ronaldo, the second element. The index in Python is 1 because index in Python start from 0. So the first element, John Wick, will have the index of 0. And if I want to access John Wick's name, I can just print patients and then 0. And if I were to run this code now, John Wick's name will be printed because this is the array, and I'm accessing the first. I'm telling Python I want the first element in the array, which is John Wick, and I print it out. So let's try it out. Let's go here and python.py. Oh, I haven't saved this, so I'm going to run this again. You can see that John Wick's name has been printed. So this is how indexing is important here. So let's go back to this question. They said this hospital number is basically a way for us to access, to tell which element do we really want. And it should be 1 to 1000 inclusive. So what they are trying to tell us here is that the patient array here should have 1000 elements. Alright? 1 to 1000. That means think of it like these are the hospital ID for this patient. And this hospital ID will help us to access the element and also the readings. I mean, I can do the same thing for readings here. If let's say my index is 0, meaning John Wick, I can do readings 0, and I will have obtained the readings for John Wick. So let me save this, and then I'm going to run this. You can see that this is the reading for John Wick. And so this is basically, just a note here, they are basically telling us that the user can enter an ID number of the hospital, of the patient number of the patient, and then we will use the data to access the element. I'll show you what it means later. So when the data for a patient is checked, a warning is given if any of the readings are out of range. If both readings are out of range, then a severe warning is given. And that's exactly what we need to do in this program. And here it is said, write the procedure using pseudocode or program code that meets the following requirement. So just for your information, procedure is basically functions in Python, and they are a specific type of function that does not return a value. Alright, does not return a value. So let's try to write the function out. The way we write function in Python is to use the def keyword followed by the name of the function. So since this function, the purpose of it is to check the condition of the patient, I'm going to do patient's condition here. I'm going to name it as patient condition, and they want us to take the hospital number as a parameter. So I'm just going to follow what it says for now. If you don't get it, it's okay. And now we need to check whether the number is valid. And we know that valid number is from 1 all the way to 1000. Okay, 1 to 1000. Meaning 0 and 1001 will not be accepted. So we need to do an if statement here. If hospital number that the user enters is less than 1, meaning like 0, -5, or if it is more than 1000, like 1001, I'm gonna output an error message as mentioned here. Output an error message. Print output mean Python is print. Hey, you have entered a number that is out of range. Alright. I'm also going to exceed the procedure. And in Python function, the way you can exceed the procedure is that you can use the return keyword. Exceed procedure basically means if I have a code print hello here, then when Python sees this return, they will not execute line 27. They will just exceed from the function, and this line of code will not be considered. Alright, so I'm going to delete this. And if the Python code doesn't reach 27, mean that the hospital number is valid. So if the hospital number is valid, I'm going to do this part of the code here. First of all, I'm going to output the patient's name. And before I do that, I want to create a new variable called patient's index. Let me explain later. Hospital number -1. And I want to do this just because Python's index starts from 0. Alright? We know that if the user needs the first patient here, meaning John Wick, they will enter the number 1, right? So in essence, we can say that John Wick here has ID of 1. But we know that in Python, to access John Wick's data, you need to use 0 instead because index in Python starts from 0. So what I'm going to do is that whatever the user entered in as a parameter for a hospital number, I'm going to just minus by 1. So if the hospital number is entered is 2, meaning they want C Ronaldo data, but I'm going to subtract it by 1 so that I got the index that I can access later. And upon this point, everything is relatively simple. First, I need to output the patient's name. So I'm going to print out patients, the array, the 1D array, and access the patient number at patient's index. Alright? Meaning if the user entered 1 as the hospital number, I'm subtracted by 1, I got 0 as my patient index. So technically what I'm doing here is that I'm doing patients 0. If let's say the hospital number is equal to 1, which I will print out patients 0, which is John Wick's data. Alright, cool, pretty simple. Nice. Alright, so now we need to check the reading of the data here. And if the output reading, if the readings are both within range, meaning both are normal, I'm going to print out a message called normal. And we define normal by using this range here. So this is when another index that is important comes into context. For those of you who don't know how to access an element in the 2D array, this is how. We know that here I have 2 readings for each patient. And the first reading is temperature, the second reading is pulse. And if I were to access the element for this particular array, I know that I need to use the index of 0. Alright, I'm going to use 0 as the index. So maybe I don't do it here. Great. So 0 and 1. Just a side note, if let's say I want to access 37, John Wick's temperature, of course I know that this list is the first item in the readings to this array. So if I want to print it out, I can do print readings first element. If I do this here, I will print out 37 and 120, and then let's try it out. You can see that 37 and 120 is printed. But what if I only care about the temperature? Then I can do another square bracket. And if I want the first element in the first array, I'm going to do 0, 0. And I'm going to run this. You can see it, 37 is printed out. And if I want to do the second, the pulse, I'm going to do it again. So the pulse will be printed out. So this is how we access an element in the 2D array. So now I'm going to check both the temperature and the pulse rate. So what happened here is that I will create a variable here called patient's temperature. Instead of doing everything accessing again and again, I'm going to assign it to readings. Patient's index, meaning the patients that we are looking for. And then let's say it's C Ronaldo. I'm going to be looking at this because it's 1. And then if I only want the temperature, I'm going to do patient index 0. And whereas another thing is patient impulse. Impulse. I'm going to do reading index reading 1. Alright, so I got my patient's temperature and patient's pulse variable, and that's when things comes in easy. First I print out the name. I'm going to add the name. Printing patient's name. And next up, we will do check whether they are normal. Check condition. So this is what happened. I'm going to do if patient's temperature. So what is it? What is a normal temperature, right? A normal temperature is one that is above 31.6 and below 37.2. So if it's more than 31.6 and at the same time is less than 37.2, it's normal. And that's only the first condition because we still need to check the pulse. And therefore, I will use another n. By the way, I use a bracket here so that Python will check the temperature first before proceeding to the pulse. So I'm going to do patient pulse. For normal is more than 55. So let me add, I'm not sure if it will work like that. Yeah. So they can see properly, or I can make it smaller. Alright, patient pulse more than 55, and at the same time, oops, what is going on? And patient pulse is less than 100. And if this condition is met, I'm going to print, hey, your readings are normal. Alright, that's it. That's about it for the first line of code. I'll put normal readings. Second, I'll put warning and the name of the reading if one reading is out of range. What happened here is that if the user's temperature is out of range, we're going to print warning temperature out of range. But if it's the pulse, then we'll print out warning pulse is out of range. So here's when we need two different statements to check whether temperature is out of range or not. So I'm going to elif. Let's do when the temperature is out of range. So when patient's temperature is less than 31.6, meaning he's super cold, or the patient's temperature is more than 37. The reason I use or here is that both conditions, only one needs to be true for the patients to be abnormal. So if the patient's temperature is 29, it's going to be less than 31.6, but it's not going to be more than 37.2. But the temperature is still abnormal, all right? And so we have temperatures equal abnormal, but pulse is okay. Pulse is okay. So I'm going to do pulse greater than 55 and patient pulse shouldn't be like that. Patient pulse greater than 55 and patient pulse equal to less than 100, not equal to. So this is the condition. So look at when temperature is normal. It's not normal and pulse is normal. So I'm going to print out warning, your temperature is not normal. And now we can do the same thing for the condition when pulse is not normal. So I'm going to do another elif. Patient's temperature, again, let's do the temperature first. It's normal, like from 31.6 to, but in logically speaking, it's actually not normal to have such low temperature. Anyway, and then now patient pulse is not normal. We're going to patient pulse. What is the not normal range? It's not normal when it's less than 55, or it is also not normal when it's more than 100. And if this is a scenario, I'm going to print out warning. Your pulse is normal. All right. So here, that's it for our case here. Then I'll put severe warning and the name of the two impulse of two readings if both pulse and temperature is out of range. And here we actually don't need to have another elif. We can just put else, because if they're not normal, and if they are not, if the abnormality is not just temperature, it's not just patient, it's not just pulse, then both of their readings are not normal. So I'm just going to print out severe warning. Let's make it a little bit fun. You are dead. All right, great. And I'm going to exceed the procedure from here. Again, to exceed the procedure from Python, you can just put return keyword. It doesn't return anything. It's still technically a procedure. But then it's just, actually you don't need this. Python will just exit from here. All right, so that's about it. That's the whole solution. In my opinion, it's relatively simple. You just need to know, I think this is the key part, to know how to visualize the data here. Because in the exams, this data will not be shown. They will not tell you that. If you just have the information that this is a 1D and 2D array. So you really need to picture this out and write down the temperature, as in write down how you want to do it. Yeah, like giving a few examples. And I just realized we could have made this code simple by replacing 31.6 with min temp. So here's one method. You can declare it and use them later. But since I'm not using it, I can just delete it. It will make your code neater. So let's try to run it. Again, for your information, because my patient list here, they don't have 1,000 elements. So technically, I couldn't accept stuff like number 5 because I don't have just the 5 element. But what they are saying here is that this patient array should have 1,000 elements. So like should have 1,000 elements. I just didn't do it to make this stuff easy to explain. So let's try to do, just for John Wick, Sierra Ronaldo, Alexander the Great, Alan Jason. And let's look at John Wick's data. It's 37, meaning the temperature is on range, but the pulse is definitely not on range. It's not like super high. So they should print out a message to John Wick saying that, hey, your pulse is not normal. So let's try it out. So patient's condition. Since I want the data for the first person, John Wick, I'll just put number 1. So, not sure if it works, so let's run it. Oops, I have a syntax error here. So let me face. I think they don't allow me to do this line, so I'm gonna put this up, even though it's a little bit ugly. All right, so just give me a second. Great, so let's run it again. Patient's condition here, unindent. All right, let's see what happened here. So I think I need to format it. So let's not move this, because when I have this scene here, okay. And if I were to run this code, okay, let's indent them properly and check whether there's any bug. Oh, I have a, that's when you can't. Alright, so let's run this code. Patient's condition. And then I'll save this. Yeah, you see that John Wick, warning, your pulse is not normal. Whereas if I were to put this as 3, like Alexander the Great, gonna do Python, you can see Alexander the Great, your temperature is not normal, which is true. Temperature, Alexander the Great has a fever, but the pulse is normal. So I'm gonna upload this file to my YouTube channel, so you can download it and run it to play around with it, add more names. But technically, that's just the solution. And thank you for watching, and I hope you learned a lot from it. See you.